Hello all, welcome to VJD Academy. This is Anil Kumar, Faculty of Digital Electronics. Sir, up to now we have seen two types of basic gates which are NOT gate and AND gate. Now let me try to explain one more basic gate called OR gate. Here let us try to understand one more basic gate called OR gate. Sir, I told you in the previous lecture, whenever we are studying about any logic gate, we just need to remember few things which are, first one, what is its logic circuit. We just need to know logic circuit, and what is the truth table, and third one is what is the logical expression, and fourth one, number of inputs and outputs we just need to know, and fifth one, sir, what is enable input 0 condition and enable input for 1 condition. After completion of sixth point, let me explain what is commutative law and also associative law. And after completion of two laws, we just need to remember one more thing. What are the unused input conditions? Unused input conditions. We have three types of unused input conditions which we are going to learn. Sir, now let us try to understand each and every individual point. From fifth point onwards, we can expect one of the question from competitive exam point of view. Let us try to understand what is enable input 0, what is enable input 1, what is commutative law, associative law, and what are the types of unused input conditions. Let me explain each and every one. Sir, we know that here logic gate of OR gate, we can say first point logic circuit. Sir, the first point logic circuit, we can draw the logic circuit of OR gate. The symbol of OR gate is like this, and I told you it is having two inputs, one is A and B. Of course, the output Y equal to A plus B. Addition operation it is performing, which means this logic gate it is performing addition operation. Sir, here this is logic circuit, and the second thing is truth table. Here truth table is, here we have two inputs which are A and B are two inputs. Let me take the output is Y equal to A plus B. So now can I say here we have two inputs, which means n equal to 2. We know the equation called 2 power n, which means 2 square. We have 4 input combinations. The 4 input combinations are, we can say 0 0, 0 1 and 1 0 and finally 1 1. These are the 4 input combinations, sir. Based upon these 4 input combinations, let us try to add these two inputs to get output operation. Sir, here we have two inputs which are A equal to 0 and then B equal to 0. The moment when I apply A equal to 0 and B equal to 0 here, what will happen? Sir, here 0 plus 0, we can say addition operation. So output is completely 0. And now let me take the second condition. Here A equal to 0 and B equal to 1, which means A equal to 0, we can say B equal to 1. Now these two inputs A and B are going to add with the help of OR logic gate, so that 0 plus 1 we can say output is 1. And now the third condition, A equal to 1, and now let me take B equal to 0. Here the moment when we take A is 1, B 0, automatically addition operation, we can say that 1 plus 0 we have 1 output. And finally we will take A equal to 1 and also B equal to 1. The addition of 2, 1 plus 1, we can say output is 1. Sir, because these values are in binary form, when we add 1 plus 1, we can get output is 1, because the variation of binary values either 0 or 1. So we may not have 2 or 3 or something like that. When we are dealing with octal numbers, decimal numbers, hexadecimal numbers, we may get 2 or 3 or something like that when we add some two numbers. Because here we are dealing with only binary numbers, we are getting only the output is 1 when we add 1 plus 1. Sir, this is what truth table. Now we have completed 2 points, which are first one logic circuit and then second truth table. Let me take the third point, which is logical expression. Logical expression. Sir, the logical expression already we have seen, when we apply A and B are the inputs, the output is Y. Because this is a OR gate and OR gate is performing addition operation, we can say Y equal to A plus B, which is the logical expression we can say. And now after completion of third point, let me take the fourth point, sir. Here we have the number of inputs and outputs. Sir, fourth point, number of inputs and outputs. Sir, based upon the logic circuit, we can say that we have only two inputs here, A and B. Inputs are inputs, we can say 2, and output only we have Y equal to A plus B, which means output is only 1, we can say. Sir, the fourth point is also completed. Now let me take the fifth point here, enable input condition. This is what very important condition. We may get questions in the competitive exam point of view from fifth point onwards. Let me take here fifth point. What is enable input? Enable input 0 condition. Sir, let us try to understand. Here, when I take OR gate, here this is OR gate, and now I am applying, we know that this gate is having two inputs. First one is A and then second one is, I can say, B. Sir, I want to apply always B equal to 0. And now I can take A equal to different types of inputs, which are the first condition A equal to 1, and let me take A equal to 0, and let me take A equal to X, and also I can take A equal to some, we can say, square wave. I want to change the values, input values of A, and I want to keep B is always 0. Let me try to understand the behavior of the circuit so that we can say whether the enable input 0 is acting as inverter or buffer or memory element. Let us try to understand. Sir, the moment when I apply here Y equal to A plus B, I can say. The moment when I apply A equal to 1 and B equal to 0, sir, what will happen? Here A equal to 1, B equal to 0, which means it is performing addition operation. Sir, from the truth table, I can say the moment when one of the inputs is 1, the moment when one of the inputs is 1, output is automatically 1. We can say output is automatically 1. This is the logic of OR gate. And we can also think that the moment when one of the inputs is 0, the moment when one of the inputs is 0, we can say the output is another input. Sir, let me telling you again, the moment when one of the inputs is 1, or we can say the moment when one of the inputs is 1, we can say output is 1. And now the moment when one of the inputs is 0, we can say the output is one of the input. Here output is 0. This is what another input. Here the moment when one of the inputs is 0, we can say output is 1. We can say output is another input. And now we can take the third condition also. Here the moment when one of the inputs is 0, the output is 1, which means the output is one of the input. Based upon this condition, sir, can we say that the moment when we apply 0, automatically the output is another input, which means here B equal to 0, automatically the output based upon this truth table, we can say output A equal to or Y equal to 1, we can say. Sir, when we add 1 plus 0 also, we can say that here Y equal to 1 is the first answer. And now let us take here A equal to 1, B equal to 0, here A equal to 1, B equal to 0, third condition, we can say output is 1. And now let me take the second condition, A equal to 0, here A equal to 0, B equal to 0, which means A equal to 0, B equal to 0, second condition, A equal to 0, B equal to 0, output is, we can say, 0. And also we can take the our logic, when one of the input is 0, automatically output is another input, which means A equal to 0, output is 0. And now let me take the third condition, when A equal to X, A equal to X. Sir, here A equal to X and then B equal to 0. So now let us try to apply our logic. When one of the inputs is 0, automatically output is another input. Here when one of the inputs is 0, then automatically output is another input. Based upon this condition, can we say the output is X? Yes, sir. And now Here the fourth condition also, when we take fourth condition A equal to square wave, we can say because B equal to 0, automatically we will get output is square wave. Sir, based upon the behavior for this 4 condition, can I say the output is same as input of A? Yes. Because the output is same as input A, which means the circuit is acting as a buffer. Yes, the first condition we can say circuit is acting as a buffer. This is what very important point for the competitive exam, sir. Let us try to note this point. When we apply one of the input is 0 for OR gate, here the circuit is acting as a buffer. And also we can say that here the circuit is also acting as a memory element. Memory element. These 2 conditions we just need to remember, because for the competitive exam point of view, these 2 conditions are very important. And now, sir, let me take the 5th condition, 6th condition. We have completed even 5th condition, and now let me take the 6th condition. Based upon the enable input 0 condition, we can say the circuit is acting as either one buffer, or we can say second one is memory element. Memory element. 2 points are very important. And now the 6th one is, let us say enable input 0 when we apply, enable input 1 when we apply. Sir, let us try to analyze. This is R circuit. Now it is performing adding addition operation when we take A equal to and then B equal to, let me take keep on 1 and A equal to 1, 0, and the next let me take any square wave, something like that. What will happen? Sir, when A equal to 1, B equal to 1, let me take first condition here, Y equal to A plus B. Sir, let us try to understand. When A equal to 1, B equal to 1, sir, when A equal to 1, B equal to 1, output is 1 we can say. And now the second condition, A equal to 0, A equal to 0 and then B equal to 1. A equal to 0, B equal to 1, we can say second condition, output is again 1. And now the third condition here, A equal to X, A equal to X and B equal to 1. So to understand this condition, we need to go for some logic called here, the moment when one of the inputs is, the moment when one of the inputs is 1, automatically the output is 1. So based upon this logic, can I say that here B equal to 1, so one of the inputs is 1, so automatically the output is also 1 based upon this logic. So can I say third output is also 1. And now let me take the fourth output, we can say here a square wave. Sir, here a square wave, we can also say that here also B equal to 1. The moment when one of the inputs is 1, then automatically output is 1. Here whatever the input, another input A equal to either 0, X or square wave or whatever it is, here one of the inputs is 1, then automatically output is 1. Sir, based upon the 4 conditions, input conditions, can I say that the logic circuit OR gate is producing the same output? We can say this is called fixed output. This is called fixed output. This is what very important point. It is producing fixed output. No variations for the different input changes. It is always producing the same output. We can say enable input 1 condition for the OR gate, it is fixed output circuit. Now let us try to understand what is commutative law and what is associative law. Let me take the 7th case here. Commutative law, 7th point is commutative law. Commutative law. Sir, what is commutative law? If you can see, when we interchange the available input for any logic gate, when we interchange the available inputs for any logic gate, even though when we interchange the inputs, if the output of the interchanged inputs is same, then we can say that the logic circuit is satisfying commutative law. Here let us try to understand. Sir, this is what logic gate or logic gate. Here I can take A and B are the inputs. Now output Y equal to A plus B. Sir, this is logic gate A plus B. Suppose if I can interchange the input values, here I want to take B and then here I want to take, I can take A. Sir, this is logic gate and I want to perform addition operation y equal to, we can say b plus a. Suppose when I draw the truth tables of these two logic gates, if the logic gates output is same, we can say the commutative law is satisfied for the OR gate. So based upon this y equal to a plus b, and we can say y equal to b plus a, simply we can say that here y equal to a plus b, which is equal to b plus a. So based upon this expression, logical expression, we can say that the commutative law is satisfying for the OR gate. Sir, after completion of 7th point, we have left over 8th point, associative law. Let me try to explain associative law. Sir, what is meant by associative law? When we take another input for the available two inputs, and when we analyze the output of 3 input circuit, if the output, when we interchange the inputs, we can say when we interchange the inputs also, if the output is same, we can say that the circuit is satisfying associative law. Let me try to explain here. Sir, this is what OR gate, we can say A, B are the inputs, output here Y1, and now let me take another input here C. I want to connect this Y1 to C here. I want to connect this as Y2. Here Y2 equal to, we can say Y1 equal to A plus B, and now Y2 equal to Y1 plus C. So finally we can say Y2 equal to, here I want to write Y2 equal to, I can say that Y1 plus C, which means Y1 plus A plus B plus C. This is what Y2 output. And now I want to connect the circuit in a different manner. Sir, here I want to connect the circuit. Here suppose I want to interchange inputs honestly. Here B, I want to take it as C. This is what output Y1 equal to B plus C. Sir, let me take another input here. This is called A, and now I want to connect this A with Y1 output. Here I want to take one more gate, OR gate here. The output, this is Y2. Y2 equal to, we can say Y1 plus, we can say A. Sir, I want to analyze Y2 equal to Y1 plus A. Sir, here Y1 plus, Y1 means B plus C plus A. Sir, this is what Y2. Now, suppose if this Y2 and this Y2 is same, when we draw a truth table, then the circuit satisfying associative law, which means suppose if Y2 equal to A plus B plus C, which is if it is equal to B plus C, we can say the output is satisfying associative law. Now we can understand by using truth table also. If you want, you can draw a truth table so that you will understand that this logical expression is satisfying, or we can say associative law is satisfied by the OR gate. We can understand. Now let us try to understand the last point. We can say unused input. We have left over with the last point called unused input. Let us try to understand how to connect this unused input. Sir, here we have left over part 9th one, unused input conditions. Suppose when we connect here case 1, we can say case 1, when we connect here, this is OR gate. Sir, this is OR gate. We know that A and B are the inputs. Here y equal to A plus B. Suppose if I want to connect one more input here, if I can connect one more input to this logic circuit, if I can connect this one more input to the ground, we can say case 1, then the circuit is works. It can perform y equal to A plus B. This is called unused input, or floating input, or extra input, or open input, we can say that. And now case 2, suppose this is the gate, OR gate, and now here A and B are the inputs. We can say y equal to A plus B output. Sir, if I want to connect third input, here we have one more third input. If I can connect this third input to one of the inputs, we can say B, then only, even then the circuit is works. And now if I can take here, this is OR gate, can I say A and B are the inputs. If I can connect this third input to here input A also, here y equal to A plus B, the output is, or we can say the circuit works. And now let me take the third condition. For OR gate, sir, we can connect, better to connect the third input for OR gate. This is A and B. Suppose here y equal to A plus B. Suppose if this circuit is, we can say TTL. Here this is third input. Suppose if this circuit is TTL, we can use, it is better to use the third input is 0, which means TTL means TTL logic family, better to take 0. If it is ECL, emitter coupled logic family, better to take third input as 1. So these are the possible conditions to use the third input for the unused input case. So it is also a very important concept in the competitive exam point of view. So let us try to understand, let us try to remember. Whereas AND gate, sir, TTL is 1 and then ECL is 1. ECL is 0 for unused condition. So this is what OR gate, sir. Mostly we have these 5, 6, 7, 8, 9 concepts are very important for the competitive exam point of view. Thanks for watching. Please do subscribe.